Okay guys, here in this video we're going to review our systems of equations concepts. We need to find the point of intersection of the lines, and that is the solution to the system. System is two equations with two or more variables. You can have three equations with more than one equation with more than one variable. Okay, so looks like we got a little standard form action here on these two. They're both in standard form. So we're going to set up with the old XY table, the XY intercept table, finding where the graphs cross the Y and X axis. So we're going to write the equation down twice for the first one. You can put ones in front since they're both positive. The variables are both positive. You really don't need to. If you can just get rid of the X and you have -2, you don't have to divide. Okay, here y is 0, and then -2 again. So the intercepts, the y-intercept is -2, and the x-intercept is also -2. So we have those 2 points, and we take the ruler and connect them. Okay, there's my line. Now, in the other equation, -x plus y equals 6, and -x plus y equals 6. Okay, now you might want to put a 1 in. Yeah, you need to put a 1 in front of the x. Maybe not the y. You can put a 1 in front of the y, but it's not really going to change the fact. X is 0, and that's y equals 6. And if y is 0, here we have to divide though by -1. Because -1 times x is 6, so that's going to be -6. Okay, so 0, 6 is the y-intercept. And -6, 0 is the x-intercept. So 1, 2, 3, 4, 5, 6. Okay, and they're definitely going to cross. I can see that at one point. And the one point that is on both lines is the solution to the system. Okay, so here's where they cross. That looks, you can make a point there. That's -1, -2, -3, -4. So -4 on the x-axis, then you're up 2, so 2 on the y-axis. Okay. Graph went through the paper. Okay, here we're solving, we have two methods to solve systems without graphing, okay? Substitution method and the elimination method. Okay, here I do not have an x or a y by itself. This y is not by itself. It has a plus with it, okay? It has an operation with it, so it's not by itself. So I would want to use elimination here. And in the other system, I have a variable with no operations that's not being operated upon, so that would be substitution. Okay, so elimination, we want to first make sure every variable has it. See if they add to 0 right here. Well, that's 3, and that's -3, okay? I don't even care about the constants. It's got to be a variable. Okay, so I just need to multiply both equations. Now, one thing you don't want to do, you see a -2 there, don't multiply by -2. You're making this more confusing than it needs to be. Just 2 will do fine. And 5, 5, 5, 5. Okay, so 5x multiplied by 2 is 10x minus 4y multiplied by 2 is 8y. It's going to be a -8y. Just put minus for now. And then 27 times 2 is 54. Okay, now on the bottom equation, -2 multiplied by 5 is -10x. Positive 1y multiplied by 5 is just plus 5y, and then 3 times 5 is 15. Now, we don't need to change the signs, because if I add them, I already have my opposites on the 10. Okay, I don't need to change the signs. So, 10 plus -10 is 0. X has been eliminated at this point in time from the system. Set that up too. Okay, now we take a -8 plus a 5, it's -3. This minus now takes over as a negative. -3y And on the other side, 54 plus 15 is 69. So we're going to divide both sides by negative 3. And 69 divided by negative 3 is negative 23. So that's your y. Okay, now to find your x, you have to use, you can use this, this, or this. But why would I use these when the numbers are bigger? Okay, why don't we just use this one here? So 5x, I'm going to make the 4 plus negative 4y equals 27. Now I have my answer for y. My y solution is negative 23. So where there used to be negative 4y, now it's negative 4 times negative 23. Okay, that's 92. So 5x plus 92 is equal to 27. Subtract 92. So 27 minus 92 is going to be negative 65. And divide both sides of your equation by 5, and negative 65 divided by 5 is negative 13. Here, look, I'll show you. Okay. So that's a pretty high solution for the system. Obviously, I would have never found that on the graph, so it's good we have these methods. Substitution. This is my base equation. So I box the base variable and circle the other side. Now write your off base over here. Negative 2x plus y equals 18. Now you got one little problem at the beginning. Both variables should have multipliers in front of them. They should have coefficients in front of them. That is a coefficient of negative 2. This would have a coefficient of 1. Okay, now we're all set. Y is my base variable. That needs to be removed from the equation. So negative 2x plus 1, empty the parentheses, equals 18. Now extend that. And we'll be putting 1x minus 4, but I'll be making that plus negative 4. Okay, so we got a distribution here. You can write down your negative 2x. Now you can write it down, add it after the distribution. Doesn't matter. 1 times 1x is 1x, and 1 times negative 4 is negative 4 equals 18. So remember what we're trying to solve for. We're trying to find the point where the lines cross. Okay, now the x's are on both sides, so I don't want to see you doing minus, minus, or plus, plus. You add. Negative 2 plus 1 is negative 1x. Add a negative 4 equals 18. Okay, so here's my x. We add 4. That takes us to 22. Negative 1x equals 22. And then divide by negative 1. It gives me negative 22, and that's the x variable. Substitution, you got to pay attention to what variable you solve for. Sometimes it's x, sometimes it's y. In this instance, that's an x variable, so x is negative 22. Okay, in substitution, finding the second variable of intersection is very easy. You go into your base equation, and you already have the x answer, so you just replace it with negative 22. Okay, so I take 1 times negative 22 and then subtract 4, negative 26. I really don't have to show a whole heck of a lot of work from you getting that. Again, the beauty of these is I would have never found those by graphing. Like if it's 1, 2, I could have probably graphed it and found that. But I don't, it's hard to do graphs that high. Okay, story problems, the meat and potatoes of this. Underline adult ticket, student tickets, and money. Okay, an adult ticket to a school play costs $5, and a student ticket is going to cost $3. A total of $460 was collected from the sale of 120 tickets. How many student tickets, how many adult tickets were purchased? So obviously we're dealing with 3 units of measurement here. The money is dependent upon 2 variables instead of 1. So we got together. We have the adults, we have the students. We have how many? We have per and total. So money per, money total. Okay, so the total cost together is $460. So So we can eliminate that. Give me a non-money amount. You got 120, but that just says tickets, so that's together. And if I know the together but not the separate, well, we're going to have to use the X and Y variables. Delete that box on all problems. Sometimes you delete this one, sometimes you don't. Obviously not here. Okay, now the cost, you've got $5 for the adults and $3 for the students. So I write the total cost here as 5X, 3Y. Okay, we have to make a system because we have X and Y in here, okay? So I have two equations. This is one of them, and this is the other. Okay, so X plus Y equals 120, and 5X plus 3Y equals 460. All right, so I do not have a variable that is isolated. Both that as an operation, a plus. Let's not use substitution. Okay, so right away, adding here won't do any good. That'll be 6X and 4Y. Didn't do me any good. So I multiply by 5 here and by 1 here. Okay, so 1X times 5 is 5X. 1Y multiplied by 5 is 5Y. And then 120 multiplied by 5 is 600. A lot of people just keep that at 120. That's wrong. To keep the equation balanced, if you're multiplying everything here by 5, you have to multiply everything here by 5. Then we just have the identity property of multiplication on the bottom. 5X plus 3Y equals 460. Okay, add these. 5 and 5 is not 0, though. You have to do the sign change. So negative, negative, negative. That deletes the 5s from the system. Okay, 4 plus negative 3. If you write 8 down, that's wrong. You're at 2Y. And here's 140. So you divide by 2, Y is 70. So that's your students. Okay, so we know the students are 70. Now to find the other one, you can just subtract these, or if you're never going to remember that, just use the standard procedure. 1X plus 1Y equals 120. I already have my solution for Y, 70. 1X plus 70 equals 120. That'd be 50. 70 and 50. Okay, a toy factory decides to produce twice as many Batman figurines as Spider-Man figurines. Batman figurines will sell for $6 each. Spider-Man figurines will sell for $8 each. If all figurines are sold, $700 is going to be collected. How many type of each figurine will be made? Okay, so you got Batman figures and not Superman, Spider-Man. Okay. Got Marvel versus DC here. Okay. So you got 3 units. Because you got the Batman figures, the Spider-Man figures, and the money. Okay. Alright, so put B and S, Batman and Spider-Man, then together. And then how many? Per, money per, money single. Okay, $700 is together. Okay. Okay, you got any non-money entities or quantities? Not 6, not 8. Well, you got this twice. Now, you still don't know. These are still unknown, but twice means you put 2x for one and x in the other. It's not x plus 2, okay? When you're twicing something, that's multiplication by 2. An unknown multiplied by 2 is 2x. Variable's an unknown quantity, so 2x, okay? You got to get that through your head. You put x plus 2 in this problem, it's going to be a train wreck, okay? Twice is 2x and x. That's the appropriate way to write twice an unknown quantity is 2x, not x plus 2. 2 plus 2 is more than an unknown. That twice and more than not the same. Okay, so twice as many Batman figures, so 2x and x. So I don't need that, okay? I don't need this, and I got money amounts. I've got $6 for the Batman and $8 for the Spider-Man. So that gives me an expression of 8x for the, that's total, not single. I don't know where I got that. Money total. Okay, now when you're multiplying this, you don't have a plus sign, so you don't need any parentheses. You just take 2 times 6, which is 12, and put x behind the product. And you don't need a system here. You just write a straight line equation. 12x plus 8x equals 700. Just add the x's. That's 20x equals 700. Now divide by 20. And I think that's 35. Okay, I know it's 35. Okay, now find your solo x. Okay, that's your Spider-Man figures, 35. So you know that that's 35. And this would be 2 times 35, which would be 70. Okay. Okay, next page. You're buying apples and oranges at the store. You have $9.78 to spend. You need 4 pounds of apples and 3 pounds of oranges. The oranges cost 25 cents more than the apples. How much does a pound of each cost? Okay, so obviously 3 units of measurement. They're already underlined for us. Okay, so you got together, and you got apples, oranges. How many per and total? Okay, total cost together $9.78. Okay, give me some non-money amounts. Well, 4 pounds of apples, that's not money, and 3 units of oranges. Don't need that. You can add them and put 7. It ain't going to help you. It's going to be irrelevant. Okay, now cross those out after they've been placed. And that leaves us with one money amount, but it has a special adjective after it, more. Now, more is plus, x plus 0.25, and then the other one is just x, okay? More than is the plus operation, so you have to put the plus there. All right, so the oranges are x plus 0.25, and then x is the apples. Okay, so 4 times x, 4x. Now, if you have a plus sign, you need a parentheses, and you need to do a distribution of the 3 to each term. So 3 times x is 3x. 3 times 25 cents is 75 cents. Okay, and you don't need a system here either. You just write a straight equation. So 4x plus 3x plus 0.75 equals 978. Okay, so add your x's. That gives us 7x plus 0.75 equals 9.78. Subtract 75 cents from each side of the equation. That takes us down to $9.03. So 7 times x equals 9.03. Then divide by 7. And 9.03 divided by 7 is $1.29. So this x here, now I know it's $1.29. Okay, and that's apples. Now to find the unknown right next to it, you just take your $1.29 and add 25 cents onto it. Okay, people are like, you can't get decimals here. Why the heck not? It's money. Okay, $1.54. You go to the store, that perfectly makes sense. Okay, a restaurant offers 2 size dishes. All small dishes must cost the same amount, and all large dishes cost the same amount. 2 parties eat at a restaurant. The first party orders 3 small and 5 large dishes and pays $97.50. The second party orders 4 small dishes and 3 large dishes and pays $75. Find the cost of each dish. Okay, again, you got 3 units. Okay, so we got together, and And then the small and the large are the two independent units working together in the system. And then how many per, dollars per, total. Okay, give me some total money. I see two. We got $97.50 and $75. So I better have two things here and two things here. Okay, give me some non-money amounts. Need them. 3 small, 5 large. Oh, more. 4 small, 3 large. That's not needed. Okay, now you don't have any other amounts. Well, no kidding. That's your answer. So these are both x's and these are both y's. So you're going to get 3x and 4x and 5y and 3y. Okay, leads us into a nice system. Well, not nice systems people don't like. 3x, they take longer. They're more tedious. 3x plus 5y equals $97.50. Then 4x plus 3y equals $75. Okay, you got to use elimination. That should be obvious. That's 7x, that's 8y, so they can't be added right here. You need to multiply by 4 on top, by 3 on the bottom. Okay, that's going to give us 12x plus 20y. Then I go to my calculator because a lot of people don't know 7. I know I don't. 97.50 times 4, 390. And then at the bottom you got 12x plus 9y. And 75 times 3 is 225. Okay, both negative, 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 add, and now the x's are deleted from the system. 20 and negative 9 make 11y, and then 390 plus negative 225 gives me 165. So we're going to divide 165 by 11. Now it's going to be a decimal, but that doesn't matter because these are costs, okay? Now, if I'm finding units in the whole, well, I didn't get a decimal, but that's fine. So y is 15, okay? So here's my y, okay? So the large is 15. Now to find the cost of a small, use one of these two. I'm actually going to use this one because I have a decimal there. Decimals aren't real fun. It doesn't matter which one you use. So y is 15. So that means 3y is now 3 times 15. Now that's 45. Correct, 45 from each side, and that takes you to 30. 4 times x equals 30. Divide by 4, and that's, I believe, 7.5. 7.5, so $7.50.